So these things are worth remembering. So when you're remembering matrices, first thing, what is the size of a matrix? A size of a matrix is the number of rows times the number of columns. Next, the addition, subtraction. So how do you add or subtract the matrices? Remember, you just add the same positions and basic addition and basic subtraction. And the two sizes of the matrices has to be the same. The first one is A by B. The second one also has to be A by B. That has to be the same. Next, we have the scalar product of matrices. Scalar product. Here, the size of the matrix doesn't matter. You just multiply the matrix with a number. Then we have the multiplication. How do you multiply matrices? This is a bit difficult. It has a special rule, and the size, you cannot multiply every matrix with another matrix. It is not allowed. You have to make sure the column of the first matrix is the same as the row of the second matrix, and the resulting matrix will have a size of A by C. This A by C. The next thing is some special rule for square matrices. In this particular case, 2 by 2 square matrices. So here we have the determinant of a matrix. Then we have the concept of the determinant being 0 or a singular matrix. Singular matrix, which simply means that the determinant is 0. Then we have inverse of a matrix. One more thing needs to be mentioned before I end this. It's solving equation using matrices. So solving equations or system of linear equations. If we have an equation like 3x plus y equals to 2 and 2x minus y equals to 8, by the method of elimination, we would solve it like this. We would cancel off y, and when we add this, it would be like thrice x plus twice x is 5x, 8 plus 2 is 10, divided by x equals to 2. 10 divided by 5 is 2. And when we put the value of 2 in one of the equation, it turns out to be thrice 3 into 2 plus y equals to 2. I'm putting it in the first equation here, right over here. So that turns out to be y equals to thrice, 3 into 2 is 6. I keep saying thrice, I don't know why. 3 times 2 is 6. So y equals to 2 minus 6 is minus 4. So we find the solution of the equation to be x equals to 2 and y equals to minus 4. Now let's see whether the same thing can be done using matrices. But this is the trick. We write the coefficient of x and y into a matrix. So the coefficient of x is 3, the coefficient of y is 1, the coefficient of x here in the second row is 2, and here is minus 1. Then we multiply it with the variables x and y. X, y equals to, we write down the values in the other matrix, 2, 8. Now this, when we have a matrix with only one column, we call it a column vector. I'll talk about a little bit about this later on. So this is column vector. We have one column. So let's I'm going to use the inverse for this. So we write, therefore, remember in matrix we don't have any division, we use inverse. So we take this to the other side, and always remember we write it at front, not after 2, 8, this column vector, in front of the column vector. Column vector again is a matrix with only one column. So this is going to be 3, 1, 2 minus 1, the inverse of this. And remember, inverse we write it as minus 1. We don't write the inverse as 1 divided by a. Unfortunately, we don't write that. We write a to the power minus 1. So now we can move on. Let's find the inverse of this matrix. I don't think I'm going to have space over here. So let me come right over here and do it. So xy. So the inverse of this matrix is going to be 1 by determinant, which is AD minus BC. So which is 3 into minus 1 is minus 3. Minus 1 into 2 is 2. So, and we are going to change the positions here for the inverse. So this is going to be minus 1, 3. And we are going to change the signs over here, which is going to be minus 1, minus 2. We found the inverse. Now we have to multiply this. I'm going to keep the determinant over here, which is 1 by minus 6 minus 5 over here. Okay. So now let's multiply these two. So we have, okay, this is better. So we have this, we have to multiply this row with this column. Remember, we multiply this row with this column. So let me mark here. So this row with this column over here. So this is going to be minus 1 times 2 is minus 2. Then we have minus, since it's minus, I'm going to write minus instead of plus. Minus 1 into 8 is minus 8. Then we move on to the next row and do the same thing over here. So this is going to be minus 2 into 2 is minus 4, and 3 into 8 is going to be 24. So let's see how this turns out to be. This is minus 10, and this is going to be 24 minus 4 is 20. So if I multiply this scalar product now, it is much easier to do it now at the end rather than at the beginning. So minus 1 by 5 into minus 10 is 2. Minus 1 by 5 multiplied by 20 is minus 4. So this is equals to xy. So therefore x equals to 2 and y equals to minus 4. So let's check the elimination method that we got. We got 2 and minus 4, so exactly what we got over here. Now let me talk a little bit about column vectors. Column vectors. Column vectors. For column vectors, you need a little bit background about vectors. So let me tell you, vectors are represented with a line. Vector is a line with an arrow, and they are usually written as, suppose if you have a point here A, and if you have a point here O, so the vector would be called, the position vector of A is OA, and it is often written with IJ or AB. So suppose it is written as xi plus yj, or it can also be written as xa plus yb, where A contains the xy material and B contains the ij material, like that, ij materials. Now if you have a point x, y, and suppose that point is A, you can also express the vector OA in the column vector format, and it is written with a matrix that has only one column. That's called the column vector. So it is a matrix with one column. So what can we do with this? The first thing we can do is we can find the length of this line. So the length of this line, written as these two bars, not determinant this time, it's called the modulus of the vector, or the length of a line of a vector. So we write it using the Pythagorean theorem, square root of x squared plus y squared. So that's the modulus of a column vector, which is a matrix, really. It's a matrix with one column. Another thing that we can do here using matrices and using vectors is that when you have two vectors, let me write this down. Suppose you have a column vector 1, 3, and you have another column vector 5, 7, and you are asked to find the modulus of A plus B. So what you do, you first find out the value of A plus B. So A plus B is going to be the addition of the column vectors, and you're going to get 1 plus 5 is 6, 3 plus 7 is 10. Once you know this, now you can find the modulus of the column vector, which is going to be square root of the first row squared plus the second one squared. So this is going to be 100 plus 36 square root of 136. Let me just do one more example before I end this. Okay. So suppose you have a point A and it is 3, 5. You have a point B which is 4, 7. Now if I want to write this as column vector, that means the position vector, remember it's point A from the origin, and this is point B from the origin. So you write the position vector as 3, 5, which is matrix with one column or column vector. and the position vector of B is going to be 4, 7. So that's that. Now if they ask you, find the vector AB. Now there is a position vector rule. The vector AB, we can use the triangle rule or we can use the position vector rule. The position vector rule says that one vector is the difference of the final vector. So if this is AB, this point is known as the terminal point. This is known as the initial point. So the position vector of the terminal point subtract the position vector of the initial point. So that means we are going to do the column vector 4, 7 minus 3, 5, and it turns out to be 4 minus 3 is 1, 7 minus 5 is 2. So that's it. Now the question is, find the modulus vector, modulus of the vector, which means AB modulus equals to square root of this row squared, so 1 squared plus this squared, which is going to be square root of 1 plus 4, which is square root of 5. Now since this is the length of a line, we can also write modulus of vector AB as simply AB, length of the line.